Welcome to Lesson 4 of Introduction to Python. Today we'll be talking about a cool feature of Python known as Turtle. And Turtle is the 2D physical drawing aspect of Python. So let's look at this example. Turtle is able to create shapes and scenes, as we can see here, and we will go over some of the things that allow us to draw all of these items. So as we can see, this is a very simple scene of a house, a tree, and a sun. But how can we create this with code? Well, first we gotta set the scene. Unlike variables or lists, Turtle is like a separate part of Python that we need to import from another location to our computer or device. So to do this, we simply type before every Turtle command, import Turtle. We're importing all of the commands of Turtle over. And of course, as you might have noticed, when we run this program, we get the live drawing of this turtle. And we follow the path of the turtle to create the shapes. And this turtle itself, we need to create. So in order to make this turtle, we give it a name, because you have to name your turtle. And then we use turtle.turtle. And here, the capitalization of the second T is really important. Now let's set up the background of the drawing. To set up a screen, we simply create a screen as turtle.screen. Again, make sure to capitalize the S. And as we can see in our background, we have a sky blue color. And for the settings of the actual turtle, we can see that we can give a size to how thick the outline of the shapes will be. This will be denoted in pen size. The thickness as the parameter here is actually going to be in pixels, and we can see that we can also denote the speed of how fast the program is going to run. So if we go back to that slide, we can see that the program, as soon as we run it, will actually run the drawing live. And to denote the speed, we give it a number from 1 to about 100. It doesn't really matter how big you go. But to get the maximum speed, we use 0. The cool part of Turtle is that our cursor can be any shape we want. And the classic shape here will be a cursor, but we can also set it to things like an arrow, a circle, and the most fun, an actual turtle. We can also change the color of our turtle. So in this example, the name of our turtle is Painter, and here we can see that we change the color of the turtle as blue. So .pen color will allow us to change the pen color. So as you can see here, we changed the pen color to blue and then to red. And then when we run this program, it will end up drawing a line blue and red. Turtle has a limited amount of colors that you put in as strings. So as you can see, when we change the color, it is a string. And here is a full list. It's not ideal to memorize it, but it's good to have a list of references of what colors Python can access. Okay, let's go on to the actual drawing part. Feel free to type out any of the code while we go along and try it out. So after we import Turtle and create a turtle, we gotta move it forward so we actually draw something. So turtle name .forward will move it forward a certain amount of pixels. The other cool thing about Turtle is that we can move the line and we can rotate the turtle certain degrees, left and right. So we can move it forward and then move it up or move it 90 degrees this way. And the best part about simple drawing is that these commands are pretty much all you need to create basic shapes. As you might recall from learning geometry, a shape has a certain amount of angles in its sides, depending on the amount of sides it has. So like a square will have 90 degrees and an equilateral triangle will have 60 degrees. And we can see that a common formula would be 180 times the amount of sides minus 2. When you turn in Turtle, you're actually turning the cursor and not creating this angle. So if I want to create, say, a triangle, an equilateral triangle, and I want this angle to be 60 degrees, I need to make sure I turn my cursor to face from this direction west to down here. And the turn here is actually going to be 180 minus this angle. So if this angle is 60, I would say, hey Python, turn left or right 180 minus 60, which is 120 degrees. So as we can see here, we would go turtle name dot right 120 degrees. And this would create, when we go forward again, this angle of 60 degrees. So using this idea, we can create shapes. From last week's lesson, we talked about for loops, and this is really useful when we create turtle. So again, importing turtle, setting our turtle name. What we can do is we can, for a certain range, we can move our turtle forward and turn it a direction. So 180 minus 90 is still 90. So when we create a square that has 90-degree angles, we can actually just move it forward 100, turn it right 90, and then repeat this 4 times in order to get back at our original place. And this creates a basic square. For every turtle program, at the very end, we want to add turtle.done. Okay, what about a star? So a basic star, we can see we can rotate it this way, and since there are 5 sides in this star, we can create for I in range 5, star.forward, star.right, and we turn it 144 degrees. So if we go forward 50, we can end up running this program and getting a star. In general, for shapes, we're going to do a pretty simple way. So we can create a program that has a side with a certain amount of numbers of sides, and this program should work and create most basic sides. So let's go through it. What it basically does is it starts a for loop of creating however many sides we have, and we move forward 100. Then we rotate a certain direction. We can create 180 times side minus 2, which again is just the formula for how many degrees is in a shape based off of the amount of sides. And then we can divide this by our current side and subtract it from 180 to get the angle we need to turn our cursor. And in this example, when we set the side number to 3, it creates a successful equilateral triangle. Another thing we can do is increment values. So a cool part of for loops is that this value here will increase as we go in range, and we can add or subtract and use this value to increment our current values. So if I want to create a spiral, right, I can go forward a certain length and increase in this length by tenfold. So if I go for I in range 20, I will range from 0 to 19. And so the first time we run it, spiral will be forward times forward, and then it will go 0 times 10, which is 0 pixels forward. And then it'll turn right 144 degrees. But the second time we go, it'll be 1, and then we'll go 1 times 10, which is 10 pixels forward, and then it'll go right 144 degrees again. And then it'll be 20 pixels, and then 30, and so on, until we are able to create an incrementing star shape. Notice that the shape of the star is created by the angles, and then the length and incrementing values is determined by our incrementing I here. So if we got rid of the times 10, this would be notably smaller, but the fact that it's increasing in size is because our I is increasing in our for loop. Now let's look at circles. We could apply the same logic and just create a shape with many sides, but Python actually just has a simple function that works, and it's just turtle name dot circle. The value here is actually going to be the radius of the circle. So in this case, the radius of the circle is 50 pixels, and therefore the diameter is 100 pixels. Sometimes when we want to create multiple shapes with space across from each other, we can kind of make our turtle float in the air. So we can pick up our pen or our turtle, and this is just done with turtlename.up. And then we can move it forward, but when we move it forward, it won't actually draw a line. so it's like flying through the air. And then when we want to set our pen back down and let our turtle go back to drawing lines, we can simply put pen name dot down. So the idea of this is that when we want to create shapes with space between each other, we need to move it up and then go forward a certain amount and then put it back down. The cool thing about it is that if we go forward or we draw shapes while the pen or the turtle is still up, it won't actually draw. So make sure that you put your turtle pen down. The final thing we're going to cover is filling in shapes. So when we fill in a shape, we need to first set a color, and then we can denote this by doing name.fillColor, and then here again we do one of the strings. And then we have to start our fill by doing name.startFill, and nothing goes into the parentheses here. Then we end up drawing our shape, so as you can see in the example, we just draw a square as we've been doing. And then at the very end, we do end fill. And here, as you can see in the example, we end up drawing a shape and filling it in the color we want. Now let's look at some examples and problems. A cool example, again, would be the spiral, where we have an incrementing value. So let's look at this question. We have name.circle 40. What does the 40 represent in this? The 40 is actually going to represent the amount of pixels that the radius of the circle will have. What about this one? Again, going forward will be the amount of pixels that we go forward with our turtle. So thank you for listening to today's lesson.